right, hello. Hi, everyone. It's great to have you at Nodes. So, as mentioned, in this session, I will give you a quick update on most notable changes in Neo4j Java Driver version 5. So, as mentioned, my name is Dmitry, and I'm a software engineer. I have been working in drivers team since January 2021, and I focus mostly on the official Neo4j Java Driver, the tooling around it, and also Neo4j Fabric. So some of the slides will actually have the green label in the top right corner. And it means that these changes are not only applicable to Java driver, but to all official Neo4j drivers. So we kind of capture them as well. So we start with release cadence. Beginning with version 5, all official Neo4j drivers will actually be released on a monthly basis. In practice, it means that there is a planned release at the end of every month. And the main motivation really is to have major and minor driver versions matching with Neo4j server, which will follow the same cadence. Obviously, patch releases will happen as and when required, depending on needs, and naturally, we recommend you to stay up to date with maintained driver versions. So, as you might know, Neo4j driver is distributed as a Maven artifact, which gets uploaded to Maven Central. In version 5, we distributed the Neo4j Java Driver artifact, the primary artifact, which actually had NetC and Project Reactor shaded into into the artifact itself. And then the rest of the dependencies were referenced using the standard Maven means. In version 4.4, we actually introduced an additional Neo4j Java Driver Slim artifact, in which NetC and Project Reactor were treated the same as any other dependency and were referenced using the standard Maven means. And users had a choice, basically, which one they like to use. Beginning with version 5, this changes a little bit. So the primary Neo4j Java Driver artifact is now effectively a Slim artifact, where NetC and Reactor are just referenced as other dependencies. But there is also a new Neo4j Java Driver All artifact that has NetC and Project Reactor shaded, and you can use that one if you wish. Talking of Java, so beginning with version 5, Java Driver requires a minimum of Java 17. 5.0 was obviously a major release and was a good point for us to do a change like that. But more importantly, there is a 4.4 Java driver that is actually a long-term support version, remains on Java 8, and works as Neo4j 5 server. So you are not under any pressure to upgrade right now. Also, actually, Java 17 is the current long-term support Java version, which also made it a very good choice for us to upgrade. It's been about 5 years since we updated Java version in Java Driver. Session creation API updates a little bit. So async session and Rx session methods on driver interface are now deprecated, but actually they remain fully functional and available in version 5. There is a new variant of session method that takes a session class as a parameter, and basically driver returns you the requested session. There is also a new base session interface that joins all sessions together. So you can basically tell driver which session you would like, and it will provide it to you as long as it supports it. On reactive side, the Rx session has been deprecated, but again, remains fully functional and available in version 5, giving you plenty of time to migrate. There are 2 new reactive sessions introduced. One uses basically Java's Flow API types, and another one uses Reactive Streams API types. So it's entirely up to you which one you would like to use. They are functionally the same, and we support both. There are some other changes in API itself. For instance, the query runner interface changed a little bit. So session.run no longer returns a result immediately, but actually returns a publisher, allowing us to report errors if there are problems communicating with the server, or giving you a result when it is actually available and we had a response from the server. This actually allowed us to simplify method keys on result, which can now return a list of strings instead of having to return a publisher, which could also throw an exception. On bookmarks side, there is a small change. So bookmark object should represent a single bookmark instead of representing 0, 1, or multiple bookmarks, which we found to be a little bit dubious. However, again, the driver will tolerate the previous behavior in version 5. Following this change, there are some small deprecations in bookmark interface. Also in sessions, the last bookmark method has been deprecated. There are obviously new methods on bookmark, to create a bookmark from a single string value and also to get a string value. And on sessions side, we introduced a new method called lastBookmarks, which returns a set of bookmarks. One of the interesting features introduced in Java version or Java Driver version 5 and other drivers is Bookmark Manager. It is technically experimental, but you can explore how it works and give us some feedback. As you know, Neo4j clusters are causally consistent. Effectively, it means that once you're done with one transaction and you start another transaction, you're supposed to provide bookmarks to the second transaction from the first transaction if you want to ensure that those changes are visible. When you use a single driver session, this is all managed automatically for you by the driver, but it gets a bit more involved when you use multiple sessions, because basically when you create a second session, you need to build a config with bookmarks from the previous session. So you need to know that you should do this. Bookmark Manager can effectively ensure causal consistency across selected sessions automatically. And it's quite easy to use. All you need to do, you need to create a config for Bookmark Manager, and there are multiple options available. Assuming if you want to integrate with another processes, there are options to provide your custom supplier or custom consumer of bookmarks. But in this example, I just provide initial bookmarks. Then you can get a default implementation of Bookmark Manager provided by the driver itself. However, you can also implement one yourself. And the way you opt into using Bookmark Manager in a session is by building a session config with this manager defined. And then effectively, you can actually use this session config in any session you create, and all the sessions will use the same Bookmark Manager. Managed Transaction API gets a slight update. So write transaction and read transaction methods are deprecated. One of the reasons for this is because we envisage this API as managed transactions. But the API actually exposed means for managing transaction by the user. So in this example, you can see transaction gets committed. However, it's completely unnecessary, because as long as this code completes successfully, driver would commit this transaction for the user. So it causes some confusion. And then in some cases, users had to return null when they were not interested in the result. And again, it's just a waste of code. So the new methods are basically called execute write without results for API types where it makes sense, and then execute read as well. So the previous example can be translated to this single liner. Functionally, pretty much the same. Talking of managed transactions and retriability, you probably know that managed transaction API benefit is that the unit of work you supply to it ensures, basically, the driver makes sure that it gets retried if there is any problem whilst executing your query. For instance, connection drops. When you use something like query runner interface exposed by session run, it gives you more control of things, but at the same time, you need to ensure that you have some retry capability on your side. And previously, it was a little bit challenging to know when exactly driver would retry it in managed transactions, because it wasn't exposed to the user. So we thought we would make it easier, and version 5 actually introduces a retriable exception interface. And as long as exception thrown implements this interface, then the driver would treat it as retriable. So if you build your own retries and you need to retry predicate, you can use the one at the bottom of this slide, and you would basically get the same retry policy as you would get on managed transactions. You might have heard of a project called Micrometer. It's a very great tool. It's a facade over different monitoring systems, allows you to avoid vendor lock-in, and actually beginning with version 4.4, driver supports Micrometer. The support is experimental, and we want to get your feedback. So if you are into Micrometer, please try it. If you are not, please explore it. It's very interesting. As long as you have Micrometer available on your class path, driver can register its meters with the global registry. And the way you enable it is by building a config with metrics adapter for Micrometer, and you create a driver. This is this simple. Talking of Java, again, obviously you might know that Java 9 introduced Java Platform Module System, which is a very great addition to Java ecosystem. It has many great benefits. like reliable configuration, strong encapsulations of modules, maintainability and security, improved performance because Java effectively can see that modules exist and can see where the classes reside. And then also it opens doors to scalable platform for Java. And beginning with version 5, Neo4j Java Driver artifact actually includes an explicit module descriptor. Module descriptor is actually a compiled version of module.info.java file. And in this file, you'll see that there is a name for the module. There is a list of packages effectively defining the public API of driver in a very explicit way. And this will be recognized both by compiler, runtime, and obviously can be recognized by you. And then also there is a list of dependencies on other modules. So when it comes to benefits, I think one of the big benefits is that this is one more project in Java ecosystem that has an explicit module descriptor and is available for use immediately. The API boundaries are clearly defined, so you no longer have to rely on some implicit package names like internal, but there is actually a very clear list of packages that are considered to be public. Obviously, module descriptor defines explicit dependencies on other modules. And again, it can be recognized by compiler, runtime, and it can be used for optimization as well. It also facilitates API boundary maintenance by us, the driver engineers, because actually driver build is configured to fail if an internal type is exposed via public API of the driver. So I think it's a very good protection measure for the driver quality as well. And this actually gets us one step closer to using driver in projects with JLink, where you can actually build a custom runtime image that only has a subset of Java that is required to run your application. The reason I'm saying is we are getting one step closer is because there are still some dependencies, like for instance, Project Reactor that is on Java 8 and does not yet define the module descriptor, but we will get there one day. This slide has a list of useful links to different resources like Java driver source code, manual, Javadoc. I encourage you to check out TestKit as well, which is our project for integration testing all our official drivers. So there are a lot of tests there, and that's how we ensure compliance among multiple drivers that we support. And the last 3 links provide you useful places where we basically announce releases. So if you want to stay up to date with the releases, you can track one of these. I hope you'll be able to get a hold of slides after the presentation. And on this, we conclude this session. I will do my best to answer questions in the chat, or if you have some time left, I can try doing it now as well.
Thank you very much for being with us today. I can see a few comments and questions. So yeah, definitely go to the chat to answer those. We have now a few minute break and we'll be back for the next session very shortly. Thank you.
See you.